Right, what we're going to do now is going to look at using the double angle theorems here and how we can simplify other expressions down. So here's a question: simplify phi sine theta cos theta to something, right? Now if we look, it looks a little bit similar to this one here. You know, we've got 2 sine theta cos theta, but we've got 5 sine theta. Now if I start with this, if I write this, sine 2 theta equals 2 sine theta cos theta, right? Now if I halve that, first of all, if I halve that, then remember, whatever you do to one side, you've got to do to the other. Then I'd have a half sine 2 theta is sine theta cos theta, right? And now if I times it by 5, okay, if I times that by 5 now, then I'd have 5 sine theta cos theta. But then here I'd have 5 over 2 sine 2 theta, right? Now look, we've got our 5 sine theta, but that's equivalent to this. So we've simplified it. 5 over 2 sine 2 theta. There we go. So we kind of simplified it. Now, I use the word simplified, but they may say show that this equals this, right? And we've done that here. So we've shown that that equals this. Okay, right. Let's look at some more like this. Let's go down some of the roots. Okay, so second one. Okay, let me scroll so we can see this here. So our notes, right? Number 2. Simplify the following. 2 sine squared 3a take away 2 cos squared 3a. Right, we have to simplify that. Now if we go through our different rules, okay, we've got a choice now. If you look at it, the one that's kind of got something squared, cos squared something and sine squared something is this one, but it just looks a little bit different, right? Okay, so we need to, we're clearly going to use that one, right? So let's think about what we can do with it. Now let's start with, okay, let me draw a square. Let's start with this. Let's start with cos 2 theta equals cos squared theta minus sine squared theta, right? Okay, now first of all, this is the opposite way around. The sine squared is at the front here, and this is being subtracted in. Now if I times it by minus 1, if I times this by minus 1, if I times both sides by minus 1, okay, I'd have a minus cos 2 theta, I'd have a minus cos squared theta, and then this would turn into a plus sine squared theta, right? Okay, but a nicer way to write this, I would write sine squared theta take away cos squared theta, right? Then that's the same as minus cos 2 theta, right? So we're just kind of like reversing the order by timesing it by minus 1. Now, but here's the thing though. Right, what can we do with this first of all? Because we've got something like this now, but what can we do first of all? First of all, we have a 2 here and a 2 here. So let's factor that out first. So put a big bracket, factor out the 2. What do we have here? We have a sine squared 3a take away cos squared 3a. They're beginning to look a bit more like this. Now, right, what can we do with this? Well, if you look at this, it's sine squared of an angle, just happens to be 3 times something, and then sine squared of the same thing here. Now, if I make theta equal to 3a here, well, what do we have? We have a sine squared, and I just replace theta with 3a, and have a 3a take away a cos squared 3a. And I'll replace that theta as well with a 3a, so I'll have a minus cos 2 3a, right? Okay, so, right, we've pretty much got it really, and the only difference is, well, so this bit in the bracket is equivalent to that, and I can replace it with this. So what do I have? I have a 2, a big bracket, okay, and inside the bracket I've got a minus cos 2 lots of 3a. Right, okay, so let's get rid of the bracket completely. The 2 is going to multiply that, so I'll have a minus 2 cos, and that 2 is going to multiply the 3a, so I have a 6a. So this statement is equivalent to minus 2 cos 6a. There you go. We've simplified it to something like that. Right, okay. Then let's look at another one. Let's look at a horrible one. Let's look at a fractional one, okay? Right, let's look at the simplifying this one. Sine theta minus cos theta equals... over sine squared theta minus cos squared theta. Right, this looks pretty nasty. And so we need to simplify this as best as we can. So what can we do? Right, how can we go about doing this? Right, let me think. Really should have worked this out beforehand, but never mind. Right, okay, yes, right, okay, we can do something with this. First of all, we can do something with that. Right, there's no one way to, there's no one right way to do it. There's the way that gets you to the answer, effectively. So let's look at this, and we need to just remind ourselves, okay, about something. If you remember, double brackets of the form like this: x plus 5, x take away 5. Can you remember that you can work this out quickly because you've got the same bracket, x plus 5, bracket x take away 5. They can simplify to x squared take away 25. Do you remember the difference of two squares, right? And if you see something like this, if you had something like x squared take away, let's say 49, then the double brackets would be x plus 7, x minus 7, if you recall, right? It's the difference of two squares. We can do something like that. We can generalize this, actually. If you had a squared take away a b squared, that's the same as doing a plus b bracket a take away b. That would actually, if you expand that out, you just get that, right? So we can do something with this because we've got a difference of two squares. Something squared take away something else squared. So sine squared theta take away cos squared theta. We've got a double bracket here. We've got a sine theta plus cos theta. Oh, hang on. Let me actually. I'll tell you what. That's a stupid place to start writing that, isn't it? Really. Let me do it further to the left. Sine squared theta take away cos squared theta equals bracket sine theta add cos theta, just like here, a add b, bracket sine theta take away cos theta, right? A take away b, right? That's if you expand that out, you'd get that. The middle two terms would cancel. So what we'll do is this. We can put a bracket around this. There's no harm in doing that. Let's put a bracket around that. So what we have on top, we have sine theta take away cos theta. And then underneath, we've got, well, this can be replaced with these two brackets. So we have a bracket around that. We have a sine theta plus cos theta bracket sine theta take away cos theta. Now, what we have is we've got the same bracket on top and bottom. We've got a bracket here, sine theta take away cos theta, and the same bracket on the bottom. So they effectively cancel each other out, and all we're left with is 1 over sine theta plus cos theta. There we go, simplified it. Job done. That's it, 1 over that. Right, okay, let's look at, we've got time, yeah, got 15 minutes, let's sorry, we've got 15 minutes max. Right, a couple of more minutes left. Okay, let's look at another one, right. Let's make this the last one then, right. Sine 2 alpha take away sine alpha over cos 2 alpha take away cos alpha plus 1. Right, let's simplify this. And we actually we want to show it. We want to show that it equals tan alpha, right? So this whole thing simplifies to tan alpha. Let's do that first. Okay, let's work that out now. Now, right, clearly we can do something with this, right? Okay, because we know what that is, right? So well, let's replace that top bit first of all. So that is the same as, remember, 2 sine alpha cos alpha, right? So let's replace that. 2 sine alpha cos alpha, and then we'll just copy that minus sine alpha in. Okay, what can we do with here? Right, well, we've got all causes apart from this +1 on the bottom. So let's replace that with 2 cos squared alpha. You need to just play about with this. 2 cos squared alpha take away 1. Let's replace this with that. So on the bottom we'll have a 2 cos squared alpha plus 1 minus cos alpha plus 1. Right, now if you can cancel things out, you should do. So what can we cancel out? We've got a +1. Hang on, what have we got here? Oh no, it's not +1, is it? Why have I put +1? It's a takeaway 1. Bop. It's a takeaway 1. Right, takeaway 1. Okay, so we've got a takeaway 1 and a +1 here. So those two cancel each other out. So what are we left with now? So we're left with 2 sine alpha cos alpha minus sine alpha over 2 cos squared alpha minus cos alpha. Right, what can we do now? Right, if in doubt, factorize. So let's see, can we factorize something out from the top? Yes, we can. We have a sine alpha and another sine alpha, so we can take one of them out, sine alpha, bracket. What have we got left in the bracket? If we take that out, we've got a 2 cos alpha minus, and that'd have to be a 1, right? Because I'd multiply it by sine alpha, so that'll be a 1. Over, okay, what have I got here? Well, I've got cos squared alpha, so I've got 2 of them really. You know, cos alpha is cos squared alpha, right? So I've got 2 of them here, and I've got 1 there, so I can factor out cos alpha. What have I got here left? So if I factor out one of them, I've got 2 cos alpha, subtract 1. Alright, okay, so we're there now. Alright, we've got the same bracket on top and bottom, so they can go. And what are we left with? We are left with, okay, I really should have a nice straight line with this, because OCD's kicking here right now. I'm not liking this, but never mind. Sine alpha over cos alpha, that's what we're left with. And what is that equivalent to? Well, we know what that is. Sine of something divided by cos of the same thing is tan alpha. So we've done it, we've shown it, there we go. That whole thing simplifies to that. Job done.